Hey folks, my name is Ms. Midha, and today we're going to focus on the following question. How do we use technology to calculate the area under a curve? So with the help of statistical technology today, we're going to use the mean and standard deviation of a data set to estimate the interval given various proportions. So let's go ahead and get started. Okay, here's our situation for the day. The wait times at a popular restaurant are approximately normally distributed. The mean wait time is 24.3 minutes with a standard deviation of 3.2 minutes. Use technology to estimate the wait times for the described group of diners. So the first situation asks us to describe the number of minutes diners have to wait if their wait times are in the longest 10% of wait times for diners at this restaurant. And the second question asks us to describe the number of minutes diners have to wait if their wait times are in the shortest 15% of wait times for diners at this restaurant. Now, just a reminder, what technology is this referring to? It is referring to the Geogebra probability calculator, which you can find at this website right here. Now, if you're unfamiliar with the Geogebra probability calculator, I definitely encourage you to check out the video from day 8 because that goes a little bit more in depth with how to use it. But if you are familiar with that probability calculator, you can go ahead and pause the video and take as long as you need to set up your normal curve given the information here, and then answer these two questions. Once you think you have everything done, unpause the video and we will review. Okay, so what I have done here is pretty much split the screen so we can look at the GeoGebra probability calculator alongside with the information that we need to answer our questions and set up our normal curve. So it says the mean wait time is 24.3 minutes. So I'm going to go ahead and change this 0 right here to 24.3, and I am just typing it in. And then it's telling us our standard deviation is 3.2 minutes. So I'm going to change this number right here. Remember, that's our symbol for standard deviation. So I'm going to change that 1 to a 3.2. Okay, we now have a normal curve with a mean of 24.3 and a standard deviation of 3.2. Now, just a reminder, these 3 buttons are very important to help us answer all of our questions, right? This button right here, this is for a left-sided distribution. The button on the farthest right is our right-sided distribution. And then this button right here, it's a closed interval. And we're going to be using all 3 of these buttons to answer all of the questions for the day. I am just going to go ahead and click on the right-sided distribution. It's a right-bounded interval just to show you. Everything has now been shaded, right? So what is that telling me? Right now, this is telling me that 100% of the total area has been shaded. And I can see that, I can verify that by looking at this number right here. Right? This is a 1. So it's saying 100% of the total area has been shaded here. Okay, I'm mentioning that because that is going to help us answer these 2 questions. So here are 2 questions from earlier. Describe the number of minutes diners have to wait if their wait time is in the longest 10% of wait times for diners at this restaurant. Well, if I'm looking at the longest 10% of wait times for diners at this restaurant, what I want to do is really focus on the right side of my normal curve, right? These are the longest number of minutes here, right? 28, 29, 30, all the way up to 34, 35, 36, so on and so forth. So if I'm looking for the longest 10%, I'm going to change this 1, because remember this 1 meant that it was 100% of the area under the curve. I'm going to change this to 0.1, and that's 10%, right? I could write 0.10, or I could just write 0.1. So what is that telling me? Well, what I can see here is that I have the longest 10% of wait times shaded, and I can tell that it's 10% by this number. But this number right here, this is the number that's actually telling me how many minutes is included in the longest 10% of my wait times, right? So I can tell right now, well, what are the number of minutes? The number of minutes are approximately 28.4. And again, I can see that right here. So we're going to say that approximately 28.4 minutes or more is going to represent the longest 10% of wait times for diners. Okay, now what about the second question? Well, the second question is asking about the shortest 15% of wait time. So that means I have to look at this side of my normal curve, right? The shortest wait times are going to be in the lower number of minutes. So since I'm going to be looking at my left side of my normal curve, I'm going to click on this button right here, right? The left-sided distribution. And when I click on it, I now have to find out the shortest 15%. So So I'm going to change this number right here. Right now it's shaded 90%. I'm going to change this to 0.15. Okay, so what have I found out now? Well, I just found out how many minutes are in that shortest 15%. How many minutes is it? It's right here, right? So how many minutes is this? It's going to be approximately 20, and I'll move my mouse right here so we can see it. It's going to be approximately 20.9 minutes or less. So I used this GeoGebra probability calculator to help us, first of all, create our normal curve given the information that we have here, and then kind of determine the number of minutes in the longest 10% of wait times and the shortest 15% of wait times. Okay, we're going to look at a couple of more questions using the same given information. So you definitely want to keep your GeoGebra probability calculator open and think about everything we've talked about to answer the next batch of questions. So here we go. All right, let's continue. So to find the wait times of the middle 50% of wait times for diners, draw an example of a normal distribution and shade approximately the middle 50% of the area under the curve. Once you've done that, answer these three questions. What percentage of the total area is unshaded to the left of the region you shaded? What percentage of the total area is unshaded to the right of the region you shaded? And then answer, the shaded region is between which two values? All right, one more time, pause the video and take as long as you need to answer these questions and as also to draw that example of a normal distribution. Once you think you have everything done, go ahead and unpause the video and we will continue. Okay, so this is an example of what the normal distribution where 50% has been shaded, the middle 50% of the area under the curve has been shaded, right? You'll notice it's right in the middle and it is 50% of the area under the curve. I'm going to show you what this looks like on the GeoGebra calculator as well. So here is what that middle 50% of the area under the curve, that middle 50% shaded, this is what it looks like on the GeoGebra graphing calculator. I'm sorry, probability calculator. And so what I did was that I did click on this button right here. Again, this was the closed interval button. And essentially just kind of moved these little black triangles around to help guide me to find 50%, right? I wanted it to be 50%. I wanted it to be the middle 50%. So I used these little buttons right here, these black triangles, to move them around. And then I kept moving them and moving them and moving them until I actually hit 50%. Okay, I'm gonna fix that up in just a second, but what we're gonna do is we're gonna use this one more time to answer those questions about the percentages of the shaded and unshaded regions. So let's go ahead and get started with that. Okay, so you should see the questions as well as the probability calculator on your screen now. And let's just get to it. So the first question is asking us to find what percentage of the total area is unshaded to the left of the region that you shaded. Well, what we know is that we have shaded the middle 50% of our curve, right? So the middle 50% has been shaded, and that's 50% of the total area under the curve. So if we're looking at the total area that's unshaded to the left, well, we know that we had 50% left over, right? We shaded 50%, and we know that this area on the left, as well as the area on the right, it's basically been split up, right? It's been split up pretty evenly. So that actually tells us that the percentage of the total area that is unshaded to the left of the region that we shaded is 25%, right? So 25% of the total area is unshaded on the left. Okay. Now, one additional thing, I know it doesn't say it here, but I'm still going to ask it because it'll help us for later. How many minutes is that? How many minutes is the 25% of the total area that's unshaded on the left? Well, let's go ahead and take a look at those values right here. All right, we've got these two values right here. And if I'm looking at the total area that's unshaded on the left, this number right here is actually going to give me that answer. Right? That's the 25% of the total area that's unshaded on the left. That's the actual number of minutes. So we can also write down that approximately 22.14 minutes, that marks the line between the regions. Okay, now the second question, very similar question, right? Instead of asking about the area that is unshaded to the left of the region, we're now looking at the area that is unshaded to the right of the region. Well, let's think about what we said for the first question, right? We knew that the area under the curve that is to the left of the region that we shaded was 25%. So that means that the area to the right of the region we shaded, that also has to be 25%. So 25% of the total area is unshaded on the right. And I'm going to ask the same question from before. What does that mean about the number of minutes? How many minutes is that? Well, again, since we're looking at the total area that's unshaded to the right, we're going to take a look at this number right here, right? This number right here, oh, my mouse is going a little crazy. This number right here is telling us, well, the 25% of the total area that's unshaded in the right, that represents 26.46 minutes. So we can actually write that, right? We can say that approximately 26.46 minutes marks the line between the regions. Okay, now what's nice about this, what's nice about all of this is now that we figured that out, now that we figured out the number of minutes that's being represented by the total area unshaded to the left and the total area unshaded to the right, we actually have our answer for this last question here, right? The shaded region is between which two areas? Well, again, if I just sort of focus on these two values right here, it's my closed interval telling me that the middle 50% of the area under the curve has been shaded. Well, that's telling me that these are the two values that are going to be, that the shaded region is between these two values. So what would I write for this last question? I would write that approximately 22.14 minutes and 26.46 minutes is what's shaded, right? The shaded region is between these two values, 22.14 minutes and 26.46 minutes. Okay, just to summarize what we did today, we basically used technology once again, right? We used this technology, this Geogebra probability calculator, and we used the mean and the standard deviation of a data set to estimate the intervals given various proportions. And you could do this with any sort of situation, right? If you're given a mean and you're given a standard deviation, you can use this technology, this GeoGebra probability calculator, to help you answer all types of questions.